Hi guys, hoping we are great. In this video we're going to talk about trigonometric identity, and our focus is using the reciprocal identities. Okay, so we have on our screen SOHCAHTOA, our mnemonic device, which we use to remind ourselves of the trig functions or the trig ratios. I believe we still remember those. That is sine theta, opposite over hypotenuse, we got cos theta, adjacent over hypotenuse, and lastly but not the least, we've got tan theta, which is equal to opposite over adjacent. So these three are the ones which are referred to as the trig ratios, and sometimes also referred to as the trig functions. But before we can go further talking about this, I want us to understand that the topic of trig identities focuses on dealing on rather replacing one function with another in order to solve an equation, even to prove an identity. So now let's look at these ratios and their reciprocals, and then we are going to look at one or maybe two examples. So the first one that we can look at is sine theta. So we've got sine theta, which is equal to, as we already said above, we're saying this is opposite over hypotenuse. So now we are saying that this has a reciprocal, and its reciprocal becomes hypotenuse over opposite. Okay, so now this particular reciprocal we have right here, it has a special name so that we do not continue calling it the reciprocal of sine. It has got a name that has been given to it, which is cosec. So therefore, we're saying this is equal to cosec. So we can establish that cosec theta is equal to the reciprocal of sine theta, of which cosec simply comes from the complement of secant, of which we know that secant is simply a line that cuts 2 points on a circle. So that's that. So we're saying cosec is equal to the inverse or the reciprocal of sine theta. Now let's look at the other one, which is cos theta. So cos theta, adjacent over hypotenuse, and also its reciprocal will now become hypotenuse over adjacent. And just like the previous one, this one also has a special name, and it is known as secant. I'm sure most of you are already familiar with the name. So therefore we are saying secant theta is equal to the reciprocal of cos theta. Lastly but not the least, we got the tangent. So saying tan theta, which is the opposite over adjacent, and we are saying its reciprocal will become adjacent over opposite, and likewise this has a name. It is called cotangent, which is abbreviated as cot theta. Therefore we are saying cot theta is equal to 1 over tan theta. Right. So now remember we mentioned something earlier on. We said the main focus in dealing with identities is replacing one function with another in order to solve an equation or even to prove an identity. But before we can go any further, I want us to look at this particular example. So now we have something like 2 sine x divided by cosec x is equal to 2 sine squared x. So how do we know that this identity is true? So we simply begin with the left side as usual. So 2 sine x remains as 2 sine x, nothing to change about it. But when it comes to cosec, we know that cosec is simply the reciprocal of sine. So I'm going to say over sine x. And this now can be easily done by multiplying. So if we're now multiplying, it simply means that the numerator becomes the denominator, and this finally now becomes 2 sine squared x is equal to 2 sine squared x, which is very true. So now, before we go any further, I want us to realize that these can also be expressed in a number of ways. So we started with sine. Let's do this. So we said cosec x is equal to 1 over sine x. Now, when we cross multiply this one and that one, it will give us cosec x sine x is equal to 1. Sorry about that. Let's just get back. Okay, so this is where we are. Let's just clear some space for our work. So this is where we are right now. So when we are to divide both sides with cosec x, let's just do it properly. Cosec x, and we also divide on the other side with cosec x. So this goes away, that goes away. We can also establish to say sine x is also equal to 1 over cosec x. So that is true, and we also know that this also is true. Cosec x is equal to 1 over sine x. So there's a number of different ways in which these can actually be expressed, but in whichever